Hello, and in this lecture we're going to be looking at gradient. So first I'll start off with a kind of a general description of what gradient is. It's basically a description of how one property changes with another property. So take, for example, your like a mountain or a hill like this. The gradient of the hill changes. So basically it's saying how does the steepness of the hill change as you go along the hill. But in this section we're only looking at the straight line, so I'll take you over to this example. You could say, how does the steepness of the builder change as he climbs up the roof? Now, because this is a straight line, you'll see that the steepness, the rate at which he goes up, if he goes up 1 meter here, he'll increase the same amount of height that if he climbed another 1 meter. So the rate at which the height increases as he goes up the roof is constant. So a few things about the straight line. Like I just said, the gradient of a straight line is constant, and it basically describes how the y value will change as you move in the x direction. So you could think of this as it will tell you how the height off the ground that the builder will reach as he moves further along the roof. So the formula for gradient is m, which is the sign for gradient, is equal to the change in y over the change in x. And this can also be written as m for gradient equals y2 minus y1 over x2 minus x1, where y2 minus y1 just is equivalent to the change in y. So take a look at this really simple example here, where we have the point A and B, where A is at the origin and B is at point 3, 3. So we can take this equation where m equals y2 minus y1 over x2 minus x1, and we'll just even label these x1, y1, x2, y2, and that equals y2 equals 3 minus y1 is 0 over 3 minus 0 equals 3 over 3 equals 1. So this means that for every 1 unit you move along in x, you'll increase 1 unit in y. Okay, so the next lecture I'll go on to do some examples. Thank you.